The story of the F-35 Lightning II and the Su-57 Felon represents one of the most fascinating rivalries in modern aviation. These two aircraft stand as the crowning achievements of Western and Eastern aerospace engineering, embodying decades of research, technological evolution, and strategic ambition. The United States and Russia have long been locked in an unspoken contest of air power superiority, and as the world enters 2025, the comparison between the F-35 and Su-57 is not just about two machines, it is about the philosophies, economies, and military doctrines that shaped them. Both jets are fifth-generation fighters that define the cutting edge of stealth, situational awareness, and multi-role capability, and their potential encounter or comparison in real-world scenarios represents a defining moment for global military aviation. The F-35 Lightning II was born from the Joint Strike Fighter program, initiated by the United States in the 1990s, to create a single, versatile fighter that could serve multiple branches of the military. The result was a family of aircraft with advanced stealth, unparalleled avionics, and network-centric warfare capability. The three main variants, the F-35A for the Air Force, F-35B for the Marine Corps with short takeoff and vertical landing ability, and F-35C for carrier operations, share more than 80% commonality in components, but serve distinct operational roles. This design philosophy emphasizes interoperability, cost efficiency, and global scalability, making the F-35 a central piece of Western defense alliances. By 2025, over 1,000 F-35s are operational across the globe, forming the backbone of NATO's air forces and representing a shift toward unified digital combat platforms. The Su-57, on the other hand, is Russia's answer to Western air dominance. Designed by Sukhoi as part of the PAK-FA program, it was envisioned as a multi-role stealth fighter capable of outperforming fourth-generation adversaries like the F-15 and Eurofighter Typhoon, while also posing a credible challenge to the F-22 and F-35. The Su-57's development was marked by technological hurdles and budgetary constraints, yet its completion symbolizes Russia's determination to remain a top-tier air power despite limited resources. The aircraft combines stealth shaping, high maneuverability, and powerful sensors with the flexibility of both air-to-air and air-to-ground missions. Where the F-35 relies on information superiority and advanced electronics, the Su-57 embraces agility, raw performance, and innovative aerodynamic design, reflecting a more traditional yet evolving Russian approach to air combat. The two jets, though both classified as fifth-generation fighters, differ profoundly in philosophy. The F-35 is designed as an information node in a larger network, a flying computer that can share, process, and act on battlefield data in real time. It prioritizes situational awareness, stealth, and coordinated tactics over raw dogfighting prowess. The Su-57, conversely, seeks to merge the stealth and sensor capabilities of modern warfare with the super-maneuverability that defines Soviet design doctrine. It incorporates thrust vectoring engines, advanced radar, and internal weapon bays to maintain stealth while retaining the ability to dominate close combat engagements. This philosophical divergence illustrates the broader contrast between the United States' reliance on precision and data dominance and Russia's focus on pilot skill, flexibility, and aircraft performance in diverse combat environments. In 2025, the competition between the F-35 and Su-57 takes on new relevance. The global security environment is shifting, with new regions investing heavily in next-generation air power. The proliferation of the F-35 among NATO allies and partners has created a networked ecosystem of fighters capable of coordinated operations across vast distances. Countries such as Japan, South Korea, Israel, and the United Kingdom have integrated the aircraft into their defense frameworks, further amplifying its reach and influence. The Su-57, while produced in smaller numbers, has begun entering active service with the Russian Aerospace forces and is being offered to select export partners. India, after initially participating in the FGFA, first-generation fighter aircraft program, stepped away, but other nations have expressed interest, such as Algeria and Vietnam. This evolving global presence sets the stage for a more balanced distribution of advanced technology, where both aircraft symbolize distinct yet equally powerful visions of 21st-century warfare.
Technologically, the F-35's strength lies in its fusion of sensors and computing. The aircraft's distributed aperture system provides 360-degree coverage, allowing the pilot to perceive threats beyond the limits of traditional line-of-sight instruments. Combined with the electro-optical targeting system and the active electronically stand array radar, the F-35 acts less like a single fighter and more like a mobile command center. It can detect, identify, and engage targets before being detected itself, an advantage that redefines the concept of first look, first shot, first kill. The helmet-mounted display gives pilots an augmented reality view of the battlefield, allowing them to see through the aircraft and visualize threats and allies in real time. This level of integration reduces pilot load and enhances decision-making under pressure. The aircraft's data links allow it to share information instantly with other assets, from drones to ground stations to ships, making it a central piece of network-centric warfare. The Su-57 counters this with its own array of innovative systems. Its N036 Bielko radar suite includes multiple AESA radars positioned across the airframe, providing both frontal and side coverage, an unusual feature that enhances situational awareness and targeting flexibility. The Su-57 also features an advanced infrared search and track system, allowing it to detect stealthy aircraft that may evade radar. The emphasis on thrust vectoring and aerodynamic refinement enables the aircraft to perform extreme maneuvers, giving it an edge in close-range combat scenarios. The Su-57's weapons suite includes a range of beyond visual range missiles, precision-guided bombs, and potentially hypersonic weapons, all carried internally to maintain stealth. This combination of stealth, sensors, and agility presents a formidable challenge to any adversary relying solely on long-range engagements. Performance metrics between them are often debated, though they serve different purposes. The F-35's top speed of around Mach 1.6 is modest compared to the Su-57's Mach 2. But the F-35's design emphasizes low observability and efficiency in multi-role operations over sheer speed. The Su-57's higher thrust and supercruise capability allow it to maintain supersonic flight without afterburners, offering an advantage in specific scenarios. However, the F-35 compensates with its advanced stealth coating and radar-absorbent materials, reducing its radar cross-section to levels that make it nearly invisible to most detection systems. The Su-57 stealth is effective but less refined, prioritizing aerodynamic performance and weapon versatility over absolute radar invisibility. This difference underscores their distinct design priorities, one built for digital dominance and coalition warfare, the other for flexibility and raw performance. As 2025 unfolds, both aircraft are undergoing continuous evolution. The F-35 program, initially plagued by cost overruns and software delays, has matured into a capable and reliable platform. The Block 4 upgrade promises enhanced sensors, improved electronic warfare systems, and expanded weapons compatibility. The integration of artificial intelligence and predictive maintenance software further enhances operational efficiency, allowing fleets to remain mission-ready with reduced downtime. The Su-57, likewise, is transitioning from prototype to mass production, with newer variants incorporating upgraded engines known as Izdeliye 30. These engines promise improved thrust-to-weight ratios, reduced infrared signatures, and greater reliability. Additionally, the integration of domestic avionics and composite materials reflects Russia's effort to make the aircraft more self-sufficient amid sanctions and supply chain challenges. The F-35's global ecosystem represents one of its greatest strengths. Its wide adoption ensures that the aircraft is not an isolated platform, but part of a worldwide defense architecture. Allied nations share training, maintenance procedures, and software updates, creating interoperability across continents. When F-35s from different countries operate together, they can seamlessly share targeting data, sensor feeds, and mission information, multiplying their collective effectiveness. This level of cooperation is unprecedented in military aviation and reflects the strategic foresight of building a fighter that transcends national boundaries. In contrast, the Su-57, while less globally integrated, benefits from Russia's emphasis on adaptability and cost efficiency. It is designed to operate from rougher airfields, tolerate harsher conditions, and function effectively with less logistical support, qualities highly valued in the diverse environments where Russian forces might be deployed. The human element remains central to both aircraft success. Pilots of the F-35 undergo rigorous training that emphasizes systems management and tactical coordination rather than traditional dogfighting. They are trained to act as decision-makers in a data-rich environment, interpreting sensor information to guide operations across multiple domains. The Su-57's pilots are trained to exploit the aircraft's agility and maneuverability, mastering high-G maneuvers and close-range combat techniques. This difference reflects the cultural and doctrinal divergence between Western and Russian air power traditions. Yet both approaches lead to capable and confident pilots who embody the strengths of their respective systems. In strategic terms, 2025 is a pivotal year because both fighters are transitioning from developmental to operational maturity. Exercises, simulations, and potential.
The ongoing evolution of the F-35 and Su-57 programs demonstrates that modern air power is no longer defined by isolated platforms, but by networks of capability. Both aircraft serve as the centerpieces of broader ecosystems that include satellites, drones, ground-based sensors, and advanced communication systems. The age of a lone ace winning the skies has given way to a new paradigm where information dominance and technological integration determine victory. The F-35, with its advanced data fusion and stealth capabilities, and the Su-57, with its emphasis on supermaneuverability and sensor diversity, exemplify two philosophies converging toward the same goal: control of the battlespace in the most complex air defense environments humanity has ever built. As 2025 unfolds, the technological maturity of both aircraft is transforming the way nations think about deterrence, air superiority, and even the definition of a pilot's role in warfare. The F-35's philosophy is deeply rooted in the idea of networked combat. Its developers envisioned a fighter that could see and know more than any adversary, and then share that knowledge instantly across all domains. This idea stems from the United States' understanding of modern warfare as a system of systems: land, sea, air, space, and cyber, all linked by an invisible web of data. The F-35's architecture reflects this, with its mission systems designed to gather information from every available sensor, fuse it into a coherent picture, and display it in a way that simplifies the pilot's decision-making process. The result is an aircraft that serves as a force multiplier. When one F-35 takes flight, it enhances the effectiveness of every friendly asset within its network. Its ability to integrate seamlessly with AWACS, surface-to-air systems, naval vessels, and ground troops ensures that it remains central to coalition warfare. By 2025, the aircraft's software and hardware upgrades have made it even more capable of operating as a digital node, reducing the fog of war for entire formations. Meanwhile, Russia's Su-57 takes a different path to the same objective. The design embodies the belief that air superiority still depends on agility, endurance, and tactical flexibility. Its aerodynamic layout, featuring forward-swept wing root extensions and blended body surfaces, allows exceptional lift and maneuverability. The aircraft's use of thrust vectoring nozzles grants it the ability to perform high angle of attack maneuvers, enabling evasive actions and unconventional attack profiles that could confound opponents relying solely on radar and missile guidance. The Su-57's focus on combining stealth with agility offers a hybrid approach to fifth-generation design, one that favors versatility over complete radar invisibility. This balance reflects Russia's operational needs. Its pilots must be ready for engagements across vast and diverse terrains, from European plains to Arctic skies and Asian mountain ranges. The aircraft's robust construction and multi-environment adaptability make it a pragmatic yet technologically ambitious platform. In the global context of 2025, these differing design philosophies resonate with their respective geopolitical strategies. The United States uses the F-35 as a tool of alliance building, supplying it to partner nations and fostering interoperability across borders. Every nation that flies the F-35 effectively joins a larger digital defense network led by the United States. This arrangement enhances collective defense, but also ties the participating nations to a shared technological and logistical infrastructure. Software updates, maintenance protocols, and mission data files are all part of a unified system, ensuring consistency but also dependence. The result is a powerful deterrent system based on shared intelligence and coordination, allowing nations like Japan, the United Kingdom, and Poland to respond swiftly to threats while maintaining strategic cohesion. It also creates a ripple effect in defense procurement, as countries without the F-35 must consider whether their existing fleets can survive in a battlefield dominated by its presence. The Su-57's role in Russia's strategy is more individualistic but equally symbolic. It represents technological resilience and sovereignty. In the face of economic sanctions and global competition, Russia's ability to develop and field a stealth fighter on its own terms is a statement of national capability. The Su-57's design reflects Russia's unique priorities. It can operate from semi-prepared runways, carry diverse weapons including air-to-surface and anti-ship missiles, and perform missions ranging from interception to ground attack. The aircraft's large internal weapons bays allow it to carry heavy payloads while maintaining reduced radar visibility, and its modular avionics architecture supports future upgrades without complete redesign. These traits give Russia flexibility to adapt its fighter to evolving tactical needs without depending on international supply chains. The Su-57, in essence, is as much a symbol of independence as it is an operational asset. One of the most intriguing aspects of the F-35 and Su-57 comparison lies in their sensor suites and data processing capabilities. The F-35 sensor fusion remains one of its greatest advantages. Every input, from radar, electro-optical systems, infrared sensors, and external data links, is merged into a single, coherent picture displayed on the pilot's helmet visor. This fusion allows instantaneous target prioritization and threat analysis, effectively making the F-35 pilot a battlefield commander rather than a simple operator. In contrast, the Su-57 employs a distributed sensor network with multiple radar arrays located across its fuselage, wings, and even tail booms. This gives it 360-degree coverage, improving its ability to detect targets from multiple angles. Additionally, its infrared search and track system, known as OLS-50M, can detect stealth aircraft by heat signature, offering an alternative method of engagement when radar effectiveness is reduced. While the F-35 systems focus on data integration, the Su-57's focus on sensor diversity gives it flexibility against a range of threats, especially in electronic warfare conditions. Electronic warfare itself is an area of increasing importance as both aircraft mature. The F-35 incorporates an advanced suite capable of detecting and jamming enemy radar, communications, and missile guidance systems. Its software-driven architecture allows new countermeasure techniques to be introduced through updates, meaning its defensive capabilities evolve faster than traditional hardware systems. This adaptability gives the F-35 an advantage in environments where threats constantly change, as is the case in modern conflicts. The Su-57, for its part, features powerful electronic countermeasure systems of its own, integrated within its airframe and supported by its onboard computer. Russian doctrine emphasizes the use of electronic deception and false target generation, and the Su-57 is expected to continue this tradition. Both aircraft are not only hunters, but also defenders in the electromagnetic spectrum, where control over signals can decide life or death long before a missile is fired. Another factor that shapes their rivalry is stealth technology. The F-35's radar cross-section is extraordinarily low, achieved through meticulous shaping, specialized coatings, and attention to every surface angle. This stealth gives it the ability to enter contested airspace undetected, strike and withdraw before adversaries can react. Its stealth is not absolute. It depends on maintenance, environmental conditions, and the frequencies of opposing radar systems, but it remains one of the most advanced applications of low observability on any operational fighter. The Su-57 stealth is less extreme, prioritizing aerodynamic performance and maintainability over pure radar invisibility. Its radar cross-section is higher than that of the F-35, but its shape and materials still significantly reduce detectability compared to earlier generations. Russia's approach to stealth is practical. Instead of pursuing complete invisibility, it seeks to delay detection and reduce engagement ranges, allowing its agility and electronic countermeasures to close the gap. This approach makes sense within Russia's defense doctrine, which values ruggedness and versatility as much as stealth.
In operational practice, the F-35's greatest asset may be its ability to serve as a data hub for other systems. In exercises, F-35s have demonstrated the ability to guide missiles launched by other aircraft, direct drones, and even coordinate naval strikes. This level of integration transforms the aircraft into an aerial command post capable of orchestrating complex multi-domain operations. In the future, the F-35 will likely serve as the brain of autonomous swarm formations, using artificial intelligence to control loyal wingman drones that extend its reach and survivability. The Su-57 is also moving in this direction, with Russia developing the S-70 Okhotnik B stealth drone designed to operate in conjunction with manned fighters. In recent tests, Su-57 pilots have successfully controlled Okhotnik drones remotely, signaling Russia's commitment to manned-unmanned teaming. Both nations recognize that the future of air combat lies not just in better aircraft, but in the synergy between human intelligence and machine precision. As for combat readiness, both aircraft continue to progress through their respective milestones. The F-35 has participated in real-world operations, including strikes in the Middle East conducted by Israel, proving its capability in contested environments. These missions validated decades of design philosophy, emphasizing stealth and situational awareness over raw performance. The Su-57 has also seen limited combat use in Syria, where it was deployed for testing under real operational conditions. Russian pilots gathered data on radar signatures, weapon accuracy, and system reliability in a live environment, accelerating the program's maturity. These deployments, while brief, provided valuable lessons that shaped subsequent production models. Both aircraft have thus crossed the line between theory and practice, demonstrating that their concepts work in real conflict zones. From an industrial perspective, the F-35 program has created